So we want to continue looking at recursive sequences. Here we have some exercises, and we're told to find the terms of the recursive sequence up to f of 4. So here, first of all, we have f of 0, right? F of 0 is 3. So our initial term, our 0th term, is 3. And then we're defined recursively that the n plus 1th term is 3 times the nth term plus 7. That's for n greater than or equal to 0. So let's say we want to find, well, we already have f of 0. Let's write that down as 3. I want to find f of 1. That's what, 3 times the previous term, f of 0, plus 7. In other words, what, 3 times 3 plus 7. 9 plus 7, that's 16, right? 16. How about f of 2? F of 2 is going to be 3 times the previous term, f of 1, plus 7. In other words, 3 times the previous term was 16, right, plus 7. 3 times 16 is, let's see, 48. 48 plus 7 is 55. All right, f of 3 is next. That's what, 3 times the previous term, f of 2 plus, yep, that's a plus. Get rid of that dot there. Plus 7. In other words, 3 times, what was f of 2? F of 2 was the previous term, 55, plus 7. 3 times 55. That's 165 plus 7, 172. And finally, f of 4. Three times f of 3, right? F of 4 is 3 times f of 3 plus 7. In other words, 3 times, what was f of 3? 172 plus 7. I don't know what 3 times 172 is. Let me get a calculator here. What is it? 3 times 172. That's 516 plus 7. 516 plus 7 is, yep, 523. So there are the terms from 0 to 4. So 3, 16, 55, 172, 523. All right, let's see. Let's do one more example. How about an exercise 2? So our initial term here, the 0th term is going to be 3. So f of 0 is 3. And we're going to find f of n plus 1. The successive term is going to be 3 times the previous term, f of n, and over 3. So that's exponentiated. 3 raised to the f of n over 3. This is for n greater than or equal to 0. So let's find the first several terms up to f of 4. We got f of 0. F of 0, here we go. It's 3. F of 1. That's going to be what? 3 raised to the f of 0 over 3. So that over 3 is in the exponent. So we got 3 raised to the f of 0 was 3, and then that's over 3. So in other words, 3 to the 3 over 3 is 1, 3 to the 1 is 3. All right, f of 2. Come on. Come on. This is going to be what? F of 2 is going to be 3 raised to the f of 1 over 3. In other words, 3 raised to the f of 1 was 3 over 3. So we have 3 to the 3 over 3, 3 to the 1, which is 3. Hey, this dude's repeating, isn't it? Let's do f of 3. F of 3 is going to be 3 raised to the f of 2 over 3. In other words, 3 raised to the f of 2 was 3, and then over 3. So 3 to the 3 over 3, 3 to the 1, which is 3. And then finally f of 4, 3 to the f of 3 over 3. That's 3 to the, well, f of 3 was 3, and then that's over 3, so 3 to the 1, 3. So it looks like this is just a stationary sequence, right? It's 3, 3, 3, 3. It's just repeating. Yep. What else can we do? Ah, right. Okay, so I'm going to have a sequence in closed form, and I want to figure out what is a recursive definition. So exercises. Give a recursive definition. Definition. For the sequence, a sub n. Oh, for n greater than or equal to 1. So we're going to start off with a sub 1, then a sub 2, then a sub 3, and so on. Okay, so here's our number 1. We have our sequence in a nice closed formula, but it's not defined recursively. So we have what? 4n minus 2 is our a sub n. Remember, we're starting at n and going, starting at n equals 1 and going up. So you start at 1 and you go up. So let's write some terms just to get the hang of this. All right, so we have what? First we can plug in 1. So we plug in 1, a sub 1. It's going to be 4 times 1 minus 2. It's going to be what? 4 minus 2 is 2. Then a sub 2. A sub 2 is going to be 4 times 2 minus 2. That's what? 8 minus 2 is 6. And a sub 3. 4 times 3 minus 2. It's going to be what? 12 minus 2 is 10. And what? A sub 4. 4 times 4 minus 2. 16 minus 2 is 14. And etc., right? Dot, 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 etc. You could, maybe you start seeing a pattern. Start seeing a pattern. So I'm going to write down a recursive definition for this. That's my goal, is to write a recursive definition. The blue here on the side was just to see a pattern. Recursive definition. So first of all, we need an initial term. So our initial term is going to be a1. a1 is 2. So we'll just say a1 is 2. Now notice what's happening from term to term. Term to term. You have a common difference of 4 every time, right? You're adding 4. Imagine you're what, plus 4. From 2 to 6, you're going 4. From 6 to 4, you're adding, 6 to 10, you're adding 4. From 10 to 14, you're adding 4. So you have a common difference of 4. Common difference. We'll call that D for short. Equals 4. So, to find the nth plus 1th term of the sequence, you're going to take the nth term and add 4. And this is for n greater than or equal to 1. Right? For n greater than or equal to 1. So I already have a1 is 2. So if I wanted to find a2, I would plug in 1 for the n, and I would get what? a2 is a1 plus 4. And then if I wanted to find a3, I would plug in 2 for n. I get what? a3 equals a2 plus 4, so on and so forth. Here's our recursive definition right here. Let's do another example of having a sequence in closed form and then putting it in recursive form, just to get some feel for this kind of thing. Let's see. Let's call this number 2. So here my closed sequence is a sub n equals 1 plus negative 1 in parentheses, and that negative 1 is raised to the nth power. And here we're talking about n is greater than or equal to 1. So I want to start off by looking at some early terms. I'm going to start off with a1, right? 1 is the first input I can plug in for n. So a1 is going to be 1 plus, parentheses, negative 1 to the 1th power. So in other words, what? 1 plus negative 1, which is 0. So a1 is going to be 0. a2 is going to be 1 plus negative 1 to the 2nd power. In other words, 1 plus 1, which is 2. So the second term is 2. a3 is going to be 1 plus negative 1 to the 3rd power. Well, negative 1 to the 3rd power is negative 1, so we got 1 plus negative 1 is 0. And a to the 4, a sub 4, rather, a sub 4, that's the 4th term, is 1 plus negative 1 to the 4th power. And going to the 4th power is 1, so you got 1 plus 1 is 2. So you kind of see what's going on. It's kind of going back and forth. Going back and forth. So notice here when I have an odd term, I have 0, right? And when I have an even term, even terms are in yellow. I got the double stars in yellow. I got 2. So what we could do is set up a recursive definition. Recursive definition of the sequence. So we're going to have initial terms a1, which is 0, and a2, which is 2. So you have the green types, right, and the yellow types. Now, notice that if you go 2 steps ahead from a1 to a3, we're going to be the same, right? We're going to be the same. a1 and a3 will be the same. If you went ahead 2 more, a3 and a5 would be the same. If you went ahead 2 more, a5 and a7 would be the same. So those that are just a difference of 2 apart are going to be the same. Right, so the first term and the third term, the third term and the fifth term, the fifth term and the 7th term. And that's actually true also for the even terms, right? If you look at the even terms, a2 and a4 are going to be the same. a4 and a6 are going to be the same. a6 and a7 are going to be the same. So what we can say in general is a sub n is equal to a sub n minus 2. And this is for n greater than or equal to 3. Greater than or equal to 3. So why do we say greater than or equal to 3? Well, we have A1, we have A2. So to find AN in general, the next one would be 3, right? A3. So A3 would be equal to, so if I plug a 3 in there for N, A3 would be equal to A3 minus 2, A1. And then if I wanted to look at A4, I would put a 4N for N. So I'd have A4 is equal to A4 minus 2, so A4 is equal to A2. Yeah, so here's my recursive definition.